Okay, welcome everybody. Today is going to be, we're going to be talking about global maximums and minimums because today is just one period. It's an easy lesson, hopefully easy for you to digest. It's not so complicated at all. And actually, it ties back to something we talked about 2 classes ago. It's actually related to intervals of increase and decrease and the first derivative. It has nothing to do with concavity. I'm doing it today just because it's a standalone, easy lesson to kind of figure out in one period. So today we're going to be talking about global maximums and minimums, and the goal is to be able to find these global maximums and minimums on some interval. Before we begin, if you wouldn't mind, please hit the like button so that this benefits the YouTube algorithm. Now, if for whatever reason you don't want to press the like button, if you don't like the video, what you can do is, instead of disliking the video, you can click the like button twice and it'll accomplish the same thing because you negated your original like. Okay? All right, so let's begin. Just pause here and jot down everything that you see on the screen. We're going to be considering a curve below on the interval from A to E. I probably should have used a different letter. E here does not represent Euler's constant. It's just some random constant. So you have a function defined from A to E, and the function's curve looks like this. And what I want to do is classify some of the points on here. Now, I'm using lowercase letters to represent the x coordinates of these special points, and then we're using uppercase letters to represent the actual points. Let's first classify point B and point D. Point B here, it's called a local minimum, and so you might remember that from an earlier lesson. To the left of point B, the function's decreasing. To the right, it's increasing. And so the sign of the first derivative is changing from negative to positive. So B here is a local minimum. D here is also the same local minimum. Function's going from decreasing to increasing. So I'm going to jot these down. So point B and D are local minimums. Okay, point C, it's right here. Function goes from increasing to decreasing. First derivative goes from positive to negative. This function is a local maximum. Point E here is at the very end, and this point is a point that we haven't quite talked about yet. Before we talk about point E, I want to just talk about point C and what the word local here means. So if you imagine looking in the locality of point C, if you imagine looking near point C, the y values, or the y coordinate of point C, is the highest y value in the locality or near point C. Okay, so point C has the highest y value in its locality, close to it. Okay, now we know that that's not the highest y value that the curve achieves in this interval, because we can clearly see that point E seems to have a y coordinate that's larger than the y coordinate of point C. So it seems that point E, its y values are larger, and so it's kind of its own maximum, but we don't call it a local maximum because it's the highest y value that the curve achieves. We call this not local, but the opposite of local. We call that global. So we call that like a global maximum. There's a funny story around this. Last year with my grade 12s, I asked them what they thought the opposite of local was. And I would ask you guys this too if we were in class. And the grade 12s last year said that the opposite of local is international. And I thought that was hilarious because it's true, but we don't call points international. I guess that's when you're talking about people or something. So hopefully that makes sense. By the way, I want to make an important note. And the note here, before I forget, the note here is that by definition, the local maximums and local minimums, like if you have a local max or min, it means that the derivative at some, so let's say for B and D, the derivative at some x value is 0, whatever the x value is of the local min or local max, okay? Because local mins and local maxes are stationary points, and by definition, at stationary points, the derivative is equal to 0. I don't want you to confuse that with global maximums. So here, with the global maximums, there's nothing okay, so the global maximum just means that the y coordinates are the highest. It says nothing about whether the point is stationary or not. And it says nothing about the first derivative. In fact, if anything, it says that the first derivative is undefined. And this goes back to a topic we talked about earlier on about differentiability. It's not possible for the function to be differentiable at this endpoint because it's hard to take a step in the rightward direction here. And so anyhow, the endpoints we typically exclude from the domain of the derivative. The function is not differentiable there, and so f prime doesn't really exist at the global maximums. So I don't want you to confuse the idea of first derivatives with the ideas of local and global maximums, okay? Local maximums and minimums, by definition, are stationary points. Global maximums and minimums say nothing about the fact whether a point is stationary or not. All it says is the point has a y-coordinate that's the highest on an interval, okay? That's all it's saying. In the same way, now let's take a look at point B. You'll notice point B is a local minimum here because it's the lowest the point ever goes, right, in the locality. But it's not just the local minimum, it's the global minimum. Like this point, point B, has y-coordinate that is the smallest among any other point on this curve. And so we call this the global, I'll use different color. We'll use global minimum. Okay. Now in this case, it turns out that the derivative is equal to 0, right? But so here it turns out that the derivative is equal to 0, but that's because point B is a stationary point. Okay, so in this case, it just so happens that the stationary point also lines up with being the global minimum, but the two are not related to one another. What I'm trying to say here is, if you have something that's a global maximum, for example, let's just take the example of a global max. It does not imply that the same point is a global minimum or a local minimum. Sorry, I should say. If you have a global maximum, it does not imply you have a local maximum. As in, a global maximum just has to do with the fact that it's the highest y value in that interval. That does not necessarily mean you have a local maximum, because you can have a situation like this where you have a point, it's the global maximum, but it's not a stationary point. And in the same way, if you have something that's a local maximum, it does not mean that that point is a global maximum. Okay, and this is easy to see here. Point C here is a local maximum. It is not the global maximum. Okay, so I just want you to be careful here. These implications are false. Okay, so I find students kind of get confused here. Local max mins and stationary inflections are stationary points. First derivative will always be 0. With global max and mins, you don't know. Maybe the first derivative is 0. Maybe it's undefined. Like, who knows? Okay, so hopefully that was a good introduction to global maximums and minimums. Now let's do one example. Before I move the screen, please jot everything you need down.